Welcome to the second in our series of videos on the Aurea evaluation software. This lesson gives an introduction into MGC 3130's Colibri suite parameterization using the Aurea graphical user interface. After a short introduction into the Colibri suite parameterization wizard, we will learn about possible hardware setup solutions for in-circuit parameterization in target applications. We then find out the mandatory parameterization steps for each system and how to fine-tune the other parameters in the Colibri suite. The parameterization is done to optimize the MGC 3130 features for a given customer design. We can differentiate between the mandatory basic steps, parameterization of the analog front end, AFE, that must be done for each electrode design, and optional extended parameters, which can be fine-tuned to improve the performance for selected features. Aurea provides a user-friendly wizard which allows navigating through individual parameterization steps. At any time, user manipulations are graphically indicated in real time to give full control over parameter changes and their impacts. Individual configurations can be flashed directly to the MGC 3130 or saved to a file and reloaded to other devices afterwards. For the best user experience of all GestIC features, it is mandatory to perform the parameterization steps using the final target system. Any hardware change may require an adjustment of MGC 3130 Colibri parameterization. Thus, we recommend providing the option for an in-circuit parameterization in the customer's design. For this, Aurea needs access to the MGC 3130 via the I2C interface. The most common way to connect the GestIC application with Aurea is to use the Hillstar I2C to USB bridge provided with Microchip's Hillstar development kit. In some applications, for example light switches, the MGC 3130 uses the gesture port to control the application and to trigger events. In this case, the I2C interface is not used during operation and can therefore easily be used to connect to Aurea. But this is not always the case. In many applications, the I2C interface is used to communicate with the application host processor. Thus, the application host processor needs to be disconnected from the SDA, SCL, TS, and reset lines before connecting the Hillstar I2C to USB bridge. This can be realized in two different ways. The first option is to physically disconnect the lines. This can be realized by providing connectors, jumpers, or zero-ohm resistors to disconnect the communication lines from the application processor. The second option is to configure the communication pins on the application host side as high impedance. This can be realized by holding the host controller in reset or by reconfiguring the pins as high Z via firmware. In both ways, the Hillstar I2C to USB bridge can then be used to connect to the MGC 3130. In this tutorial, and most of the following tutorials, we will be using Microchip's Hillstar development kit. Before developing your own GestIC application, you are welcome to use your own Hillstar kit to reproduce the parameterization steps described in the tutorials. To start Colibri suite parameterization in Aurea, we navigate to the Setup tab and select Parameterization. There are two sections, Basic and Extended parameterizations. The Basic section contains the AFE parameterization step, which is the only mandatory step to be adjusted for each new design. The Extended section provides all the optional parameterization steps. Let's assume, instead of the Hillstar kit, our own GestIC application is attached to Aurea. The only step which is mandatory to perform is analog front end. All features will then work out of the box. All remaining steps are intended to fine-tune GestIC functionality. The steps required to correctly parameterize the analog front end are explained in the respective video. To get access to these extended steps, we need to select which GestIC library firmware and parameters will be used. It is recommended to choose the default firmware proposed by Aurea corresponding to the latest firmware version. For the parameters, start with an existing reference file. That can be loaded from Customer File version 1.0 and newer, or you can as well start with a Microchip reference file, which is closest to your electrode design. Use Hillstar Standard Parameterization, or a file from the Hillstar HW references. Please refer to the MGC 3130 Hillstar hardware references to get pre-configured parameterization files. The package can be downloaded from the Microchip website. Make sure to choose a reference file from an electrode design which is closest to your application. For our example here, we select the default configuration for firmware and parameters. The default reference file contains the complete parameter set with default values, which are good for almost all applications. We press Start Parameterization. The firmware and the parameters are loaded to the MGC 3130 flash memory. On the left-hand side, the real-time control window shows the individual navigation steps. By selecting a step, its content will appear. We can then manipulate the parameters according to our needs. To return to the initial settings, we can press the Revert to Saved button up here. To get help on the individual parameterization steps, we can click on the Show Help button to get dedicated instructions. To close the instructions, we press the Hide Help button. Once we have finished a parameterization step, we navigate to the next step we want to adjust. For each parameterization step, a separate video tutorial is provided. Let us just quickly go through the steps. The first parameterization step adjusts the analog front end of the MGC 3130. The next step adjusts the configuration of the MGC 3130 after setup. Within the following steps, the features of the MGC 3130 can be adjusted. These are positions tracking, HMM gesture recognition, approach detection, touch detection, and air wheel. The system calibration can be adjusted in the calibration timeout step. The behavior in the event of noise can be configured in the noise power step. Gesture port is used to configure MGC 3130's extended input-output pins in case of gesture or touch events. Parameters changes are applied immediately, and the wizard provides the graphical interface to check the effect. After all of the adjustments are done, the parameterization should be flashed to the MGC 3130 or saved to a file. To demonstrate the flash to MGC 3130 or save to file functionalities, let us do a small change on the setup. We navigate to System Startup and uncheck the Air Wheel feature. To flash this Colibri Suite configuration, we need only to press the Flash button here. Once done, this button is highlighted with a green tick mark. To save this Colibri Suite configuration, we press the Save As button. We name the file and press Save. Auria stores the Colibri Suite parameterization in the same file format as the GestIC library. Both GestIC library and parameters are always stored together in the same container, having the file ending ENS. Once done, this button is highlighted with a green tick mark. The saved file can be loaded into other MGC 3130 devices by using the Flash Library File feature in the Setup tab, or it can be used by the MGC 3130 Software Development Kit, SDK, or by the MGC 3130 Production Test Software, or by the MGC 3130 Programmer to replicate both FW and parameters in a production environment. At any time, we can press the Exit button to quit the parameterization process. Auria checks then if there are some unsaved or unflashed parameters. Today, we picked up some in-circuit parameterization setup recommendations, learned how to start a Colibri parameterization, learned how to load and save parameterization files, and found out how to flash these files to the MGC 3130 controller.